Hello everyone, this is Miss Berlin and this lecture video is all about calculating the frequency and wavelength of electromagnetic waves. Since we are talking about electromagnetic waves, might as well we deal with the speed of light, and that is expressed as C equals the frequency of the wavelength multiplied to its lambda. So when we talk about the C, which mean here the celerity or the speed of the propagation of light. Again, the C means celerity. It is a Latin word which means swiftness or quick, which is only appropriate for the how fast the light travels, right? So the C stands for celerity, which means speed, quick, or swiftness. This word has been first used by Weber and Colruyt in 1856 on their paper. Now, the C here stands for or has a constant value of 3 times 10 raised to 8 meters per second. That is the value of the C. Now, we also have here the frequency, which has the unit, the frequency has the unit of hertz, which means when I talk about hertz, it's also the same with the unit S negative 1. S negative 1 and hertz are the same, they are equal. Now, when I talk about frequency, it pertains to the number of times an electromagnetic field completes a cycle per unit of time. Again, when I talk about frequency, it means the number of times an electromagnetic field completes a cycle per unit of time. So, hertz therefore stands for 1 cycle per second. So, when I talk about frequency, for example, this is the source of light and it will travel on a particular vacuum, we are dealing with how much this light has traveled back and forth or has how much vibrated per unit of time or per period. That is what we mean by frequency, the number of its oscillating particle that travels back and forth. Now we also have the lambda here. The lambda stands for the wavelength or has a unit of meter. The wavelength is the distance between two consecutive crests of a wave. So this is the crest and that is the lambda. Okay, now we're done with that. Let us deal with sample problems. We have here the sample problem 1, the basic problems. What is the frequency of red light that has a wavelength of 7 times 10 raised to negative 7 meters? Now, on this problem, we have to identify first, as always, the given value. We have the given value of 3 times 10 raised to 8 meters per second. And then that is constant and always given. Then we have the lambda or the wavelength, which is given in the problem, which is 7 times 10 raised to negative 7 meters. Here, the negative 7 meters. And then our solution would be this frequency, since the problem is being asked to find the frequency here. You have to manipulate the formula, right? Initially you have the formula of C equals frequency multiplied to lambda, correct? But then, you only need the equation for the frequency, and this equation is to the speed of light. So you have to isolate the F here, okay, to have the equation, to have this equation. So how would you do that? You divide both sides by lambda. By dividing that using the law of exponent, you will be able to cancel numerator, denominator. You know, therefore, isolated the frequency, which is frequency is equivalent to the C over the lambda. Or might as well use the basic triangle formula here. So, earlier we said the C equals F multiplied to lambda. So, that is C is equals to F multiplied to lambda, since they are in the same line. That means they are both in either numerator or denominator. So since you're looking for the F, you just have to cover this one, and then you will have the C over the lambda here. Cover this one, C over lambda. Okay, and then next thing that you need to do, since you already have the formula, you just need to substitute. So for F here, let me use my this one. For F here, you will have the value of the C. The value of the C is this one, and then you just have to substitute that here on the numerator. And then the value of the lambda, substitute in the denominator as shown in the equation. The next thing that you need to do is divide. You may use directly or you may input this directly at your calculator. No, but solving step by step, you just have to 3 divided by 7. That is 0.429 or 428 something, right? But you have to, on my case, I rounded it off, right? So I just want 2 points, the 2 decimal or 2 significant values. So 3 divided by 7 is 0.43. And then times 10, then you have 8 and negative 7 as exponent. You have 8 and negative 7. So in low exponent, whenever you divide a unit that has an expression of exponents, you have to follow the law that states in dividing, you have to subtract the exponent. So it means you have to subtract the exponent here. And by doing that, you will have 8 minus the negative 7. You do not forget that the main operation of subtraction is different from the sign of the number. They are different. So you have to perform always the operation. So 8 minus negative 7, you multiply the sign, that will become 8 plus 7. And 8 plus 7, it will become positive since they are like signs. They are both negative, and then there will be positive. And that means, therefore, the operation now that you will have is addition. 8 plus 7 is 15. And then notice your unit. You look here at the unit. You will have to cancel the units here. So you will have numerator meter, denominator meter, low exponents. You have to subtract that. They have the exponent of 1 each for the m meter, and then m meter, numerator, denominator cancel. You are left what? S here, and it is in the denominator, which is expressed as s negative 1 if it is in the denominator, and s negative 1 is hertz. Okay, so therefore you have 0.43 times 10 raised to 15 s negative 1 or seconds negative 1 or hertz. Okay, you may use either of that, but our standard unit is hertz. So next thing that I did is to properly express the number in scientific notation. So the proper way of writing a scientific notation is you have to have the decimal point at the first non-zero digit. So that is moving 1 here. Let me change the size. Moving from this decimal point to the between 4 and 3, you have moved one movement, right? 1 decimal. So that is from here to here, and that is 1 minus. Okay, if the movement is from here to here, that is minus. So 1 movement, which means 15 minus 1, and therefore you will have 4.3. Since the decimal has been moved between the 4 and 3, times 10 raised to 14. 15 minus 1 is 14, and the hertz unit. S is negative 1 is correct as well, but hertz is a standard. They have the same value. You can use S negative 1 if you want. And the final answer is that the frequency is 4.3 times 10 raised to 14 hertz. For sample problem number 2, we have what is the frequency of blue light that has a wavelength of 4.5 times 10 raised to negative 7 meters. You have the given value of 4.5 times 10 raised to negative 7 meters for the wavelength. Now, how do you solve that? You have to find the given values, and we have here C equals 3 times 10 raised to 8 meters per second, constant for speed of light. And the given from the problem is the wavelength or lambda. And then the solution is the same from the first problem we have here. And then all you need to do is substitution. The value of C is 3 times 10 raised to 8 meters per second. The value of the lambda is 4.5 times 10 raised to negative 7 meters. The next thing that you need to do, you may use directly on the calculator, input it directly, but you may do it step by step. 3 divided by 4.5, the coefficient first, 3 divided by 4.5, that is 0.75. And then the exponents, again, whenever you divide operations involving exponent, you have to subtract the exponent in division. So you have to subtract 8 minus the negative 7, and that will become 8 plus 7. They will become positive. The operation will become positive since the main operation is negative, and then the value of the exponent is negative. So plus 7, and then you will have 15 for that exponent. Then how about the unit? Meter cancel, numerator, meter, denominator cancel. You are left with the second unit, which is at the denominator. It is at the denominator of the operation here. And that will become S negative 1. That is in the denominator because you have the vinculum, right? You have the vinculum line. Even though it is in the numerator, but the main operation is in the denominator. So S negative 1 is also same as hertz. And then after that, the next that you need to do is properly express the value in scientific notation, which is moving one decimal point from here going to here, which means you have to subtract depending on the number of movements that you did. So 15, I made one movement. 15 minus 1 is 14. So the answer is 7.5. It is 7.5 because you move the decimal point between the 7 and 5. So 7.5 times 10 raised to 14 hertz. You may use S negative 1 or the hertz, whatever you want. This is the answer for sample problem number 2. Now, sample problem number 3, you have here the broadcasting frequency of a local radio station is 94.7 times 10 raised to 6 hertz. What is the wavelength of the radio wave it transmits? So the next thing that we need to do is we are being asked to find the wavelength. And yes, you have to find the given values. The given values are, you have the frequency given in the problem, 94.7 times 10 raised to 6 hertz. And then the speed of light is constant, 3 times 10 raised to 8 meters per second. The next thing you need to do is, of course, you have to manipulate the equation. From the original, you have the equation, right, of C equals frequency divided by multiplied by the lambda. And since we are talking about finding the wavelength, that means to say we have to find the lambda. We have to isolate the lambda, and we cannot use this equation. So you have to divide both sides by frequency so that you can eliminate the frequency numerator denominator and to isolate the lambda unit. Lambda is equals to C over F. Or you can use the triangle expression here. You just have to cover the lambda and then you have the C over F. You can use that. And then the next thing that you need to do is substitution. For the value of the C, you have 3 times 10 raised to 8 or 3.0 times 8 times 10 raised to 8 meters per second. And then the value frequency is 94.7 times 10 raised to 6 hertz. Now, the next thing you need to do is divide the coefficient. You have to divide 3.0 divided by 94.7. You have 0.032. And then the next thing that you need to do is, since this is a division operation, a fraction, you have to subtract the exponent. 8, the exponent, minus 6. And that is positive 2. So that is why you have 0.032 times 10 raised to 2. How about the units? We all know that this is at the denominator. And the hertz is S negative 1. And then you have the S, which is positive on here. So numerator, denominator, 1, and negative 1, S negative 1, minus 1, that is cancel. Okay, S negative 1 again, baka malito. S negative 1, minus 1, ayan, negative 1, minus negative 1 will become 1 plus, negative 1 plus 1, and that is 0. Cancel the seconds, cancel the hertz. You are left with the meter unit, and that is the final answer, 0.032 times 10 raised to 2 meters. And that concludes our lesson.